All right. Multiplying mixed numbers. This will be lesson 2-4. Okay, I'm actually going to show you two different ways to solve mixed numbers. But I will be very honest with you. The first way I'm going to just show you. I would rather you actually not do this, but I'm going to show you. Somebody may like it. I don't know. Okay, but just keep in mind the second way will probably be less confusing, and it will probably be the way that you would like to solve it. Because it's, in my opinion, it's easier. All right. With that being said, if we have a problem that looks like this, okay, so we have 1/2 times 2 3/4. Yes, those are both not mixed numbers, but one of them is. One of them's a fraction. Okay, the book sometimes asks you to use the distributive property. Okay, in my opinion, this is the harder way to do them. Okay, but maybe somebody likes it. I don't know. Okay, this is no different than if we had 5 times 21. Right? If we had 5 times 21, which one would you break up? The 21, right? You would break that up into 20 plus 1. Okay, just so that you can see a visual there. Right. So we're working on the top one. So we're going to break up the 2 and the 3/4. So we would have 1/2 times 2 plus 1/2 times 3/4. You should be able to see that that is using the distributive property, yes? Right? We distributed the 1/2 to the 2 and to the 3/4, right? That shouldn't be anything new, right? So if we do our math that we learned the other day about multiplying fractions, right? The first set of parentheses, we should get 1, right? This will simplify to 2 over 2, which gives us 1, right? Plus, if we look at our second set of parentheses, we do not and cannot cross reduce. 2 doesn't go into 3 evenly, and obviously a 1 we can't do anything with. So here we simply get 3/8. And when we put them together, we get 1 and 3/8. Okay, now that is a fairly easy distributive property using mixed numbers. Okay, now let's try it the other way. Same problem, just doing it a different way. Now, this is the way that I would prefer you to do it. Why? Because I think it's easier. 2, it's what you learned yesterday. Okay, so we're not going to distribute anything. What we're going to do is we're going to change 2 and 3/4 into an improper fraction. You familiar with this? You know how to do it. Okay, you take the base number, right, which is 2. You multiply it by the denominator. So 2 times 4 is 8. and you add the numerator. So here we are going to get 11 fourths. Once again, the denominator is never going to change, right? Going back to our example of buying pizza on Friday or Saturday night, right? A large comes with 8 slices. One of these weeks, it's not automatically just going to come with 5. They're not going to change it on you. Okay, the denominator always stays the same. Now, from here, what's the first thing that you would like to recognize? Michael? You always want to look to do something right now. Which it, yeah, you do. Yeah, if you can. If you can. You always, any, okay, in this case, we can't, but you always want to look to do that. Always. Anytime that you have fractions, whether they're proper or improper, your life will be so much easier if you can cross reduce. You always look to do that. Okay, once again, we don't like large numbers. We want smaller numbers if possible. Okay, and in this case, we can't. There's nothing that we can do. We can't cross reduce. 2 doesn't go into 11 evenly, and you got a 1 on the other side. Right? So we get 11/8, which in turn turns into 1 3/8, which is the same answer that we got. Huh? Oh yeah, it is. It is for some reason. I don't know why. Okay, so you see how we solve that? So listen carefully. If the directions say to use the distributive property, you do not have to use the distributive property. I don't, it doesn't bother me that you don't know that way to do it. Okay? We call it the improper fraction way. Turn them into improper fractions. And then from there, you need to cross reduce because the numbers are going to be larger. They're going to be larger because we're dealing with numbers that are greater than 1 significantly. Does that make sense? Okay, let's try another one. Okay, once again, you must be in delay mode. Okay. The first thing you're going to do, obviously, if you have a proper fraction, you don't need to do anything to that. Okay, but we do now need to change the mixed number into an improper one. Okay, so we take 4, multiply it by 8. What do we get? 32. 32. You always add your numerator, which is going to be what? 32 plus 3. 32 plus 3. 35. There we go. And your denominator is always going to be your denominator. Okay, Michael, what do we do now? Yes, you always listen, we don't want to multiply 4 times 35 if we don't have to. We don't want to multiply 7 times 8 if we don't have to. Okay. Does 4 go into 8 evenly? Sure does, right? So we divide by 4. We get 2. Up top, we get 1. Does 7 go into 35 evenly? Yes, it does. How many times? 5. 7 goes into 7 once. I don't know why that's happening. Okay, so if you take a look up there, in the yellow specifically, there's a lot going on. There's numbers, there's division, there's numbers, everything's crossed out. Okay. Once again, this is where I hope you're not lazy, where you take your time and rewrite the problem and really look how easy this is. That's really what we're dealing with. And when you put it in those terms, 5 divided by 2, that's going to give us 2.5. Right? That makes sense? Everybody good with that? Everybody good? Okay. Moving on. Now we have 2 mixed numbers. Bless you. We have 2 mixed numbers. 5 2/3 times 3.5. Okay, first thing you want to do is turn them into improper fractions. Okay, what's the first one going to be? 5 2/3. What's that turn into? Just yell it out. Okay, 17/3. That is correct. We're always carrying down. Times, second one, 7/2. Okay, now, this is good. What do we do now? Can we cross reduce? No. Right? 2 can't go into 17 evenly. Uh-oh. 3 can't go into 7 evenly. Uh-oh. Now we just got to multiply. Now, this happens sometimes. Okay? Sometimes it's the nature of the beast. Okay? 17 times 7. 100 who? 119. Hauser. Now, the reason I gave you this, I'd like to show you a little trick. Well, whether you can comprehend this or not, I'm not sure, but I just want to show it to you. This is something that I like to call vertical division. Okay, you do not have to do this. I'm just showing you this if this is something that you, right? Because if we were to divide this, right, you would do something like this, correct? You do that. Okay, so instead of doing that, I'm going to do it vertically. Might want to watch. Might want to watch. Okay, so follow me with this. How many 6s go into 11 without going over? 11 minus 6 is what? So I've used the 1s, and now my number is 59. How many 6s go into 59 without going over? How many? 9. 9 times 6 is? Oops, sorry. 9 times 6 is what? 54. What's 54 minus 59? What is it? There's your answer. 1 5/6. If we were to do this, do you see where I'm doing the same thing? I just did it vertically, right? What do we got here? Oh, wait a minute. Sorry. I forgot. I forgot my 9. 19 and 5, 6. Sorry, I forgot my 9. My bad. I knew that 9 went somewhere. Okay. Look here. Dropping, right? How many 6s going to 50? 8. That would be 48, right? I get a 2. Drop my 0. I get a 3. I get 18. I drop my 2. I get a 0. That 3's repeating itself, yes? Guess what 5, 6 is equal to? 8,300s repeating. That is what you're going to do tomorrow with your flashcards. You'll see. Okay, so if you can't and don't want to, it's totally up to you. Use the vertical division. Okay, you're going to have to divide it out if numbers get that big. If numbers get that big, and you may have come of some of those. How many of you like that? I'm just curious. It's new. It's new to you, I'm sure. You're not going to find that in any books. If not, then you're just going to have to straight out divide it. Okay, next one. How about that? Yeah, we're starting to get harder. Ten and 5/12 times 3 and 3/25 times the whole number 4. All right. What does 10 and 5/12 look like as a mixed, an improper fraction? 125 over 12, right? Very good. See, those are big numbers. We hope that we can cross reduce here. Times 78 over 25. Very good. Times 4 over 1. Very good. Don't lose track of putting a whole number over 1 for a fraction. All right. Talk to me. What do you want to do? Cross reduce. What do you want to cross reduce? 125 and 5. I like it. That's a 1. That would be a 5. Very good. Anything else? Does 12 go into 78 evenly? Is there a number that can go into 12 and 78 evenly? 4? 4 does not go into 78 evenly. No? 2. Okay, 2 does work. That is correct. Is there a larger number than 2 that goes into 12 and 78 evenly? That answers 3, Joe. I can't hear you. Sorry. If we divide by 3, this is a 4. Dividing by 3, this is going to give us 26. Okay. Now, we haven't encountered this. Is there anything else that we can do at this point? Look carefully. Look carefully. Chase. We can cross out the 4s. You are correct. Right? Remember, as long as one of them's on the bottom and one of them's on the top, we're in really good shape. Now, how about that? 5 times 26 is 130. 1 times 1 times 1 is 1. Now, that looked difficult when it began. Okay, the only tough calculation there was Well, cross reducing the 12 and the 78. That's correct. Now, you could have divided by 2. That's fine. Okay, and I think then you would have recognized you could still go lower. Okay, which is fine. Okay, but don't let the hard problems, I guess scary is the right word. I don't know. Okay. Again, you need to cross reduce when you can. All right. How about this? Last one, maybe. All right, so the good news here is you already have 2 proper fractions. That's the good news. Okay, because you really don't have to do anything to those as long as they're proper. Okay, what's this? 35 over 8 times 5, 6. All right, yes, we are. We're looking to cross reduce. Somebody talk to me. 4 and 8, okay? What do we want to divide by? Okay, again, if you can recognize the larger number, that will help you. Anything else? 7 and 35, right? 7 goes into those. Anything else? Can we cross off the 5s? Can we cross off the 5s? No, because they are not diagonal. They are not cross, right? Okay, so there's nothing else we can do. 1 times 5. Actually, let me clean this up because this is now what our new problem looks like. 1 times 5 is 5 times 5 is 25. 1 times 2 is 2 times 6 is 12. Hopefully we don't like that. How many 12s go into 25 without going over? That would be 2. 25 minus 24 is 1. We carry over our denominator. Our answer here is 2 and 1/12. All right. Last one. All right. Here it is. Okay, this is similar, not exactly the same, but similar to the one that you had last night. Okay, you spend 3.5 hours doing homework. You spend 1/4 of that time doing social studies homework. That's what SS stands for. Okay, here's the question. How much time do you spend doing social studies homework? Okay, I'll give you a minute to figure that out. Now, listen carefully. I would like you to put this in hours, and I would like you to figure it out in minutes. Please figure it out in hours and minutes. All right, we got anything yet? What do we have for the hour? The hour is easier than the minutes. What do you got, Michael? Okay, what do you get for the minutes? Okay, what do we get for the hour? Grant would get. Okay, so if you take 3.5, which is what it said, times 1/4, you get 7/2 times 1/4, right? You get 7/8 of an hour. You should have been able to get that for the hour. That's very similar to what we've been doing. For the minutes, Michael, how'd you get the minutes? Okay. All right. Okay, that's fine. Nothing wrong with that. Instead of doing that, because 200 and whatever you got, it's a big number. How many minutes are there in an hour? So if you take 60 times 7/8 after you get your hour over 1, right? Is there a number that can go into 8 and 60 evenly? That would be 4. That would be 15. This would be 2. So we get 105 over 2. How many 2's go in there? That's 52.5 minutes. Again, these are the types of questions that you've been seeing, you're going to continue to see, that we have to get better at. The straight drill and skill problems you're going to be fine with. All right, everybody good? Okay. All right, so we have our homework tonight for lesson 2.4. Okay, we're going to do 5 through 39, only the odds.